All right, everyone, we're going to go ahead and get started here. Let me get a few things up so I can talk to you guys. And once again, thank you for attending one of our LabChart Mastery webinar series. Today we're going to go over how to use the spectrum analysis in LabChart for Windows to analyze your data and to just basically pull more out and just to discover more about what you're recording and how to quantify your data. My name is David Ream. I'm the Technical Support Engineer here at AD Instruments North America. Judging by a few of the names I see out there, I think I've spoken to a couple of you in the past. But before we get rolling into Spectrum, I'd like to kind of go over what is happening here with WebEx, the different interfaces with me, and how to communicate with me during the webinar. So first, we'll kind of talk about the webinar guidelines. If you can't tell already, all the audio from attendees will be muted during the presentation. This is kind of just to keep background noise down in the presentation, as well as to maintain the flow of the presentation until I'm ready to field questions. The primary way you'll be able to interact with me is through the WebEx toolbar. If you're using a Windows computer, you'll see that it looks like this. If you're using Macintosh, it will look like this. And the main thing I want to kind of draw your eye to is the little caption button here. You can see what it looks like here in Windows and what it looks like here in Mac. If you click that, it'll bring open the chat window. This is your primary way to interact with me. If you have any questions during the presentation, please enter them into the chat window. Do not use the Q&A option or anything like that. And at the very end of the presentation, I'll go back over and answer those questions in the order they were asked. As far as our program today, well, pretty brief this one. We'll go over the Spectrum window display, what it all means, what is it showing us, how to set it up, how to analyze either online data or selections we've made in the chart view. Also go over the channel calculations that are available now in LabChart. Those came online in, I believe, LabChart 7.1. And we'll also talk about some of the data pad calculations, very similar to channel calculations, just in the data pad. And we're going to go ahead here and get started. 1 second here. Let me get my LabChart file open. And throughout this webinar, I'm going to be using the simulator on my PowerLab to actually put signals back in the PowerLab that we can analyze. For this first file, I'm entering in a 20 Hertz sine wave on channel 1 and an 80 Hertz sine wave on channel 2. Now, to access the spectrum view in LabChart, you would simply go to Window and scroll down to Spectrum. There's no hotkeys for this. This is your primary way to get in and actually open it up and view it. And once again, that is going to the Window menu and going and selecting Spectrum. Now, if I left-click here on Spectrum, it brings up our Spectrum view. I'm going to open it rather large here so we can kind of talk about it. We don't have any data in here right now, so obviously we're not seeing any graphs, but you'll have your power spectral density diagram right here, and your spectrogram, which is something new with LabChart 7.1. We'll talk about that more in depth later. But let me go ahead and populate this with a little bit of data, and I'm going to go ahead and do the smart tile here, which will allow us both to see the chart view as well as spectrum view. And once I'm going to do that, I just go up here and left-click the toolbar button for the smart tile. And I'm going to go ahead here and hit Start. Now, as I said before, we have a 20 Hertz sine wave going into channel 1 and an 80 Hertz sine wave going into channel 2. The colors in the power spectrum density diagram, they reflect the colors of the traces out here in LabChart. And also, there's a whole lot going down here in spectrogram. We'll talk about that. And you can see right now that I'm actually acquiring and displaying spectrum data real time. This is something that is also new with LabChart 7.1 that came on board and allows you to just monitor your signals while you're recording them. So now that we've recorded a little bit, let me go ahead and hit stop here. going to make our spectral view a little bit larger here. All right, so we have our power spectral density. There's a variety of different values we can show here. Here we have it in decibels. You can have volts squared, which I believe is power density. We'll talk about more about the different units and what it means according to the spectrum that you're recording. And basically what we're doing here is we're just doing a fast Fourier transform and converting our data over from the time to frequency domain. So we can see where the majority of the power in our signal is, at what frequency it's originating around. So since, for instance, that I'm sending this 20 hertz sine wave into channel 1, all the power is here at 20 hertz. With channel 2, let me go ahead and click over here so my trace follows. We're putting an 80 hertz sine wave in. Of course, it's going to be right around 80 hertz. All the options are available to you that are available in LabChart in the chart view, such as auto scaling, setting scale, going back to the defaults, zooming in. All the buttons that are the oldies and goodies that are out there in chart view are all available here. You can also scale your data. So we can zoom in a little bit more if we want to, make it smaller, just kind of compress the horizontal scaling. We can also auto scale to make everything fit. I'll leave it a little bit larger here so we can see better. And as I mentioned before, you can switch back and forth between the two different traces. So right now I have it set to actually follow the channel 1 trace here in the PSD. If I click here, I can actually have it follow channel 2. You can also set the channels that you want to display. So right now I'm just displaying 1 and 2. You can do all of them, none of them, or certain combinations of them. And select them through here to display channels. Also, right now we're doing the latest FFT, a single one from the very last data we've done. If I wanted to, I'm going to go ahead and smart tile again here. I could go for a specific selection. So I'm making a selection out here in LabChart. Do the selected here for those channels, or you can go back to the latest, which is where we were before. You also notice these buttons right here. These will allow us to maximize certain panes. So we can maximize the PSD pane. We can stack the spectrogram and the PSD, or we can maximize the spectrogram. Go back here and stack. And those of you who used our software for a bit in the past, either older versions or pre-7.1, you'll remember that you used to be able to actually stack these PSD views. That's not currently available. Right now they are overlaid over each other. I believe there may be some plans in the future to allow that, but at this time they're overlaid, and this is the only option you have for the PSD. Moving on to the spectrogram. The spectrogram looks a little wild at first, and you're not quite sure what it's trying to tell you. What does this mean to me? And the best way to explain the spectrogram is that it is a three-dimensional representation of the spectrum we're seeing here in the PSD. Down here, you can see that on channel 1, and it's stacking just like the PSD used to be able to. So here in channel 1, we can see we have this really hot zone at 20 hertz. And you see this is unchanging over the entire length of the file here. So your whole file is going to line up here. You get your time access. You can scroll through to see if there's any changes in the frequency. And I have an excellent example file I'm going to be opening shortly that will show us how it changes. You can see here in channel 2, we have this hot region around the 80 hertz area, which corresponds to our 80 hertz signal sine wave that we're actually putting into channel 2. Over here on the right, we have this kind of temperature or color temperature indicator, and this is kind of the third dimension I'm talking about. Obviously, really low power if we're down here in the blues, as we can see here, and your power slowly increases as it gets lighter and gets closer to yellow. So as we can see here, almost all of our power is right here at the 20 hertz region. So it would be 20 decibels is what our y-axis and the PSD is here, and what this axis is going to be. So a great way to see how your spectrum changes throughout the file. And I mentioned that I had an excellent example file for this. Let me go over here and open it up. So once again, I'm going to go here to Smart Tile. And I have the stimulator once again putting in a certain, I believe, a triangle wave and a sine wave here above different frequencies. But you'll notice here, I've set up the input on channel 1, this triangular wave or sawtooth wave, to actually, it varies its frequency over time. So you can see here in the PSD as we're recording that channel 1's frequency keeps changing between 100 and 60. Okay? While down here in channel 2, really constant sine wave of exactly 60 hertz. Now this is where you can kind of see how the PSD can be useful for you whenever you're analyzing data. If you want to know how the spectrum is changing, what is the frequency doing over time, you can see here, I'm going to go ahead and stop recording here for a second and maximize our view. And as you can tell too, you can change the colors of the spectrogram. So if you don't like whatever the default is for LabChart, you can go ahead and assign different colors. So I've decided the black and green color scheme here on channel 1. But we can see here, we can actually see the oscillation of the frequency of that signal that's going to channel 1 as it's moving back and forth between the two frequencies. And of course, down here we can see where the channel 1 is centered and how it's just staying constant. But like I said, a great way with a spectrogram to see how things are varying in your signal if you're interested in that.